swatch. When you look at the slope field, it says sketch possible solution curves through 3, 2, 1, 2, 3, and 2 means I start, oh, they put a dot there for me. That was kind of nice. And you just go in the direction that the little arrows point you in. What about 0, 8, which is starting here? Do you see that this is logistic? It's got a carrying capacity. It says the carrying capacity is 6. And if you look at that equation, you're going to say, well, I don't see where the 6 is unless you factor it. Because it has to be 1 minus. So the first thing you notice with logistics, and they're not going to give you 1 minus, they're going to give you something like this. This could be a multiple choice question saying what's the carrying capacity or what's the limit of the function. Actually, that's what they would say. But if I factor out dy dt, I'm going to factor out that 6. So it's 6 over 8y. Then that's 1 minus y over 6. How do I know I did it right? Multiply it back out. Yeah. It's logistic because there's the 1, so what's the carrying capacity? 6. They didn't ask that question on this question, but they could have. And D, I got stuck on D because it's not that hard, but you have to really be particular about it. And there's the logistic is when you get these curves. You have the equilibrium solutions, and you have the carrying capacity here, and your curves are going to look like this. Because it's some number times the population, and it's 1 minus the population over the carrying capacity. Versus, you could see this, Kp 1 minus T over K. That looks logistic, but it's not. That's a separable.
So then when you see that, how do you deal with that? That's what you
then you separate them. And we can go back and do a problem again.
we should do one of those.
Well, this one, well, let's look at this one. This one's got a lot of good stuff on it. Notice they didn't ask us to solve it. They said use Euler's method. But let's do D first because that's the one I got wrong. I said, well, what's the range? Well, range is everything bigger than 0. No, read the question again. What is the range of the function? And my function is this one. No, it's in particular, it's that function that starts with 0, 8. What is the range for this? 6 to 8. Do I get to include 8? Yes. And I said everything between 0 and well, everything positive except for 6. Well, I did it wrong. Because I just didn't read that particular part about it, even though we're talking about a particular solution. It's supposed to be, you have to go to the information desk. No, because they called you. Okay, so A, I think it's 2 points, one for each one of those curves. Should we look? Oh, they want me to give the whole thing. There it is. So I started here, but I need to finish it. It goes that way. And then I look at the picture. It's obviously logistic. Okay, B, use Euler's method. And that was 2 points, right? That was easy. Kind of like one of these. Euler's method. Now, this is totally a BC question. I don't see anything with AB on there except A could be an AB question and D could be an AB question. But I think this was totally a BC. And it does have a Taylor polynomial in there. Oh, it's not that bad. Now, you guys, on Schoology, I posted the schedule of what we're doing when, and I can't find my hard copy. Because they're talking about only this function that starts at 0, 8, not the one at 3, 2. You have to read it carefully. I got that wrong too. They're only talking about F. F starts at 0, 8. It never gets down here, does it? This is a horizontal asymptote. In this case, it never crosses that. Pardon? For A, you draw both of them. For D, what's the range? I thought it was everything. Easy to do. Okay. Yeah, let's do Euler. Should we remember what Euler is? Because I don't have the equation memorized. Okay, guys? This was a no calculator problem. Okay, shh. I need quiet. Okay, Trevor? Study session tonight. I was going to do chapter 7 stuff, get that all done. I can do polars too, or whatever else other topic you would like to look at. I have everything scheduled out with sessions. Thursday night, I'm supposed to come, but if the driving's bad, I will not come back. I'll make it up next week or something. So with Euler's method, you write the equation of the tangent line, and we'll call that x0, y0 equals m. It's x minus x0. Okay, there's Euler. So if you don't remember Euler, now's the time to maybe try some problems. Okay, Bjorn? What am I going to do? I am going to start with this point, use the slope at this point, and travel along the tangent line a certain distance. Okay, Sam and Matt? Guys, you can be quiet if you're not interested. And this length here, we're going to call h. It's the step size. Then I calculate the slope of the curve at this point, and I draw another line, just a straight line, using that slope. And I find that point. Now, I'm not on the curve, but I'm finding points pretty darn close to the curve. And the smaller my step size, the closer I'll be. So I'm actually plotting points. A slope field, you plot little direction arrows. Those are two ways to analyze a differential equation if you can't solve it. And this one, I can solve it, it's logistic, but remember, I told you they would never ask you for that solution. It's too hard to do. If you want me to do it, I can. I have to do partial fractions. Yeah, I don't want to do it either. Tell you the truth. They will never ask for it. So the next y value, call it n for next, is equal to the y value we're just at plus the slope. Well, the slope is the derivative, probably in terms of x and y. So it's the slope at that point times, and this is what we call h, the step size. You can put it in a chart, or you can just work the details out. Doesn't matter. I followed it either way when I graded it. And that's all there is. So we're going to make a table. You don't have to make a table. And I only have to do this twice, I believe. It says start at 0, two slopes of equal size to get to f of 1. So what's my step size going to be? 0.5. Okay, I'll make a little table. Rather have too big a table than not big enough. Don't you wish? Okay, so in the first column, we put how many iterations we are at. So we're starting at 0, and we started at what? What was at t equals 0? Oh, where are we starting for this function? At 8, right? It's all about that function. I think they throw us off when they do the 3, 2. That's not the function. It's the 0, 8. So here is x. Here's y. Here's 0, 8. Here's my slope. And then it's going to be y plus dy dx times the step size of 0.5. And it's the number of times we're doing it. So on the beginning, we start at 0. We're doing Euler's method. So my derivative was dy dx equals, or dt. Was it t? Sorry, dy dt is y over 8 and 6 minus y. So that's a t. Sorry. Okay, what is the slope in the beginning? It's the y value. It's 8 over 8. And then it's 6 minus 8. So what's dy dx? -2. Okay, so my new y value is going to be 8 plus negative 2 times a half. Yes, your test is tomorrow. So questions. Those of you who are talking, shh. I'm going to ask you not to do that so people who want to hear about this can. Okay, did I do it right? I'm starting at 8. The slope was negative 2, and step size was a half. Be careful that you go the right direction. This is going to the right. So that's 8 minus 1, which is 7. So the new y value is 7. What's t at that point? 0.5 or a half. It's supposed to be a t. Could be an x. But in this case, the equation was in t's. Yes. Slope. Yes. No, they will not do it. This is what you see here is what you get. Now, the difference in the way they did the exam between this year, the last year, and years before is they actually printed the problem in the books. So I'll see if there's one in here. I don't think there is. There was one last year. T, dt. Oh yeah, we'll do last year's. Or did we? We did do last year's. That's right. I asked you to do 2012 number 4, and you could each grab an exam book and score it and see what you think. Also, see what are good papers and what are not good papers. Hey guys, shh. You're gonna have your conversation, please. Hey guys, the door's right there. Go. I'm sorry. I'm giving you a choice. You can go out there and talk, or you can be quiet in here. Yes. Oh, I haven't finished it. Oh yeah, not finished. So now what's my slope? dy dt is y over 8, right? So it's 7 over 8, and then it's 6 minus 7. So what's that? Negative 7/8. Hope I did that right. Doesn't feel right, but okay. So my old y value, questions?
What's the last box?
That's the equation of the tangent line. It's y, your old y value, plus the slope, dy dt, times the step size. It's just the equation of a tangent line. I don't memorize it.
And what's the second to last box?
My slope ran over.
Oh.
Guess it didn't have enough room.
We need another box for you.
No. That's this one right here. So this is going to start at 7 plus a negative 7/8 times 1/2. Do you have to simplify that? No. So it takes 2 iterations to get here. You don't have to write that down either. What's the next t value? 1. And then that's 7 minus 7/16. Yes. Because you're going to go from t equals 0 to t equals 1. And it says 2 step sizes of equal size. So you subtract, divide by 2. Shall we see if this is getting us an ordered pair so that I can actually graph the solution. We started at 0, 8, and we said the slope's got to be negative. So and when we go to a half, we're down to 7. So we started here. When we go a step size of a half, we're right here, down to 7. Now, that's the real curve. Let me do this in red. This is the Euler one. And then we actually did this, and what's 7 minus 7/16? It's 6 and 9/16. So it hasn't dropped a whole lot when I got to 1. So when I get to 1, I'm going to do another step size. There's 1, and so it's just going to come here a little bit like that. So it's not exact. There's the exact one. It's just a little bit below it. I'm just finding ordered pairs on a graph that's close to the right one. It does not make any difference. It's all it is. It's slopes. Okay. There we go. We can recognize you use Euler's method. It's just the equation of the tangent line. It's all it is. Except you're going to continue. You'll write the equation of the tangent line at the next point. Well, it's not tangent anymore, but it's a line. And there it is. Yeah, we did do it right. So if you do Euler's method with 2 steps and you make a mistake, you're eligible for 1 out of 2 points. And if you get it right, you get both points. If you don't have any work, you get nothing. Is that okay? We're up to 4 points. This is a BC question. That's not tough. Was it? Now the next part's tough. Was that as far as we? Okay. The next part you're not going to like because it's Taylor. Now, what does this second? Now, it won't hurt us to look at this right now. This is 2008 question 6. Taylor is always in question 6. Now, if they change it on me this year, I'll be surprised because the question 6 is supposed to be the hardest. Okay, second degree Taylor polynomial. Let's review what a Taylor polynomial is. Do you remember? It's equal to f of a. And let me write it all out. It's x minus a to the 0 over 0 factorial. All you have to remember for Taylor is this. Well, yeah. And you need to know e to the x and sine of x and all that good stuff. It's 1. It's defined to be 1. Okay, Eric. Then it's f, guys, it's f prime of a, x minus a to the first power over 1 factorial. What degree am I at? Sam? Matt, what degree? I need the second one, don't I? All right. It means I have to take a derivative. Okay. And we are centering it around 0. Oh, that's nice. So it's going to be f of 0 plus f prime of 0, x plus f double prime of 0, x squared over 2. Can we all get to that point? Because it's not that hard. Can you remember the formula now? On the schedule, and it's up on Schoology. There's a link on Schoology on the updates. I have the calendar. I can print it out for you. It's just not color. The one I did is in color. If I could find it. It's here. I just don't know where. Okay, what's f of 0? We started at 8, right? What was the derivative? First derivative. We did that. What was the derivative here? Negative 2. So it's minus 2x plus, I have to do this. Zero factorial is defined to be 1. We had to define it somehow. And since the math is pretty much made up. Okay, so I got to find the second derivative. dy dt is equal to y over 8. Then it was 6 minus y. Guess what you have to do? You have to find the second derivative. Now, I thought it would be easier to distribute that. For some reason, that it was easier with the product rule. Don't ask me why. I got it right with the product rule, and I got it wrong with when I multiplied it out. So it's y over 8 times the derivative of this. What's the derivative of 6 minus y? Negative 1 times dy dt. Don't forget the chain rule. That's missed on a lot of them, by the way. We should do the bird problem. Okay, plus 6 minus y times the derivative of y over 8, which is 1/8 times dy dt. We know dy dt is negative 2. So we already did that. And what's our y value? 8. So it's 8 over 8 times a negative 2. I think I did that right. Plus, it's easy to make a mistake here. 6 minus 8, which is negative 2. Pardon? How do I know what? Because we had to use it a long time ago, right here. You could put it back in and do the extra work if you want. Times 1/8 times -2. Yes? Yes, thank you for pointing that out. Good. So it's 2 minus 4/8. So it's 2 minus a half, or 1 1/2, 3/2. I hope I did it right. I'll find out. Okay, so guess what you put right in there? 3/2. And I'm done. I would probably clean it up a little bit. Ask me what? We are not done until 11:35. Yes. I still have it. Wait, let me finish this problem, okay? Okay. Oh, I forgot to finish the problem. Did I get 5/4? Well, where are we? Okay. I got 3/4. What did I do wrong? Oh, my derivative is wrong. Okay. I should get 5/2. No, their answer is never wrong. I have -1/2, and I have 2. Oh, 2 negatives make a positive. You guys, you're not very good at helping me catch my mistakes. 2 negatives make a positive. So it's 2 1/2 or 5/2. Now, I do have to finish this. Okay, you guys? It's 8 minus 2x. 8 minus 2x, and it's 5/2 divided by 2, so it's 5/4 x squared. Okay, you guys? Then it asked me to do something else that I forgot to do. It says, use it to approximate f of 1. What's f of 1? 8 minus 2 plus 5/4. So 6 plus 1 1/4, which is 7 1/4. Now, what did Euler say it would be? Euler said it would be what? 6 9/16. I would trust Taylor before I trust Euler. I just think it's more accurate. But the more terms you get in here, the better it's going to be. Okay, so how many points was that? You got 2 points for finding the second derivative correctly. I got 1 because I goofed. Because I multiplied 2 negatives and got a negative. But you'll get 1 point for having the right process here. Then 1 point for your Taylor polynomial. If this is wrong, I don't know if we did a follow-through error. I just don't know. And then 1 point for that. Now, this is possible. No, it's not. It is a BC problem. So that's Euler's method. Did we do to? Oh, wait, I've got more on here. There's some more problems we can try.
Dude, I just had a major recollection.
How about that one?
I think I'm missing a quiz.
I'll let you try this. The second derivative is 1/25 times the derivative of that, which is dw dt. Well, what's dw dt? 1/25 w minus 300. And they asked the same question in 2012 with the bird problem, and students still got it wrong. This is the waste problem.
Will the bird problem be on our test tomorrow?
Might be. And then there's your work for your differential equation. Do you need this part? I don't believe so. because it's concave up. And when it's concave up, the tangent line is an underestimate. But you have to say it's concave up on the interval. If you don't list the interval, you didn't get the point. And announcements will be in 6th hour. So if you're not here at 6th hour, you don't get announcements. Oh, nice. You have an easy day. You want to come and help me out in my 5th hour? No. Well, it could be more productive normally. Oh, that's kind of nice. Is anybody coming tonight? I'll help with AB if you guys don't show up. 6 o'clock. I'll have my puppies. Oh, shoot. I'll have to look it up. I don't know. I wanted to be here, but they said this room was busy. So, yeah. And I'll have my chihuahuas. And I'll have my big dog. Yeah, she'll be in the forum. If you want AB topics, slope fields, differential equations, and related rates tonight. Well, you could leave it the log of 1100 because that's what I did in class. I didn't change it. When you do this, E here, it's then the absolute value of W minus 300, which clearly is positive because it's waste. Okay, is E to the T over 25, and then plus C plus the log of 1100. You could leave it that way. Yeah, you can leave it up there. I recommend. B, we had to take the second derivative. So the derivative of W is not 1, it's dW dt. So then you put dWt back in. You have to put dW dt, which is this, back in for that. It's an easy mistake to make. Most kids made the mistake. Very few people got the points for B. Well, that's only 2 points. If you get A and C, you got 7 out of 9 and it's a 5. Yeah. They must have given that to me somewhere. Does it say that? Yeah, okay. But do you have to write that? I don't think so. I don't think you had to write it. Oh, there's another good one. That's the Taylor polynomial and Euler. 2006, number 5. You'll find them. Remember, I gave you a spreadsheet, I thought. Or maybe I didn't. That has all of them on there. Did I give you a spreadsheet like this? I think I did. I do a lot of printing, so I don't even know. What? Why are they asking you to find the second derivative on this problem? This is a double bubble problem. This is an AB topic. Being able to do that? This is an AB topic. And these are BCs. Remember, it's usually question 5, 4 or 5, that you get the double bubble. So you can kind of figure out what the common questions are. Knowing that, you know number 6 is going to be Taylor. You know the vector is going to be a BC topic. So when you don't see those, You know it's going to be an AB one. So if it's AB, you know you're not going to have logistic on there. Although part of it could be. Because there's one problem that will have part AB and part BC. So you should try that one. You're not solving it. So you want to do C or D? You want to do A? Well, I got dy dx. That's pretty easy. What's dy dx? So dy dx is, at negative 1, 4, is 5 minus 6 over negative 4 minus 2. So it's 5 plus 1. Did I do that right? That's 6. Second derivative. Why did I what? It says I'm given dy dx. dy dx has a combination of x's and y's. It happens when you do implicit differentiation. You'll have both in there. Second derivative is 10x minus the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, which is dy dx, all over y minus 2 squared. I'm sorry, what? Did I copy it wrong? I did. And unfortunately, that's a penalty. Whoops. Y minus 2. I copied it there, but that's okay because it's 0. So it's 10x, so it's negative 10. That's 0. Minus 6, and dy dx was 6, all over y minus 2. Negative 4 minus 2 squared is 36. Oh. Now let's see. That's a negative, and that's a negative. So it's going to be negative 10 plus 1. I think it's negative 9. Negative 9. Good. I did that right. Is it possible for the axis to be tangent to the graph of f at some point? If the graph is tangent to the function, what has to be true about the slope? It has to be 0. So dy dx is 0. 5x squared has minus 6 over y minus 2 has to equal 0. So 5x squared is equal to 6 over y minus 2. So y minus 2 times 5x squared is equal to 6. So y is equal to 6 over 5x squared plus 2. Is that ever going to be tangent to the x-axis? In other words, is y ever going to be 0? Can y be 0? No. Now, could I have put it, I could have put the y equal to 0 probably right up in here, and got, which would have been easier, equals negative 3. Can this ever happen? X squared equals negative 3/5. No. So there are a couple ways you could prove it. Not tangent. Okay, how about the Taylor polynomial? I want second degree. And it's around what? Negative 1. So it's going to be equal to f of negative 1 plus f prime of negative 1 times x plus 1 plus f double prime of negative 1, and it's x plus 1 squared all over 2. What's f of negative 1? That was negative 4. This was 6. F double prime was negative 9, right? Negative 9? So it's negative 9 halves x plus 1 squared. That wasn't that hard. Remembering the Taylor stuff a little bit better? You just have to remember the formula. And there's usually a little trick. And that's it. That's all I had to do there. Did I do it right? For the bell rings? I did that. I did it in a weird way, but it's okay. And did I get all my signs correct on that? Looks like I did. So how much is the Taylor one? 2. Centering it at x equals -1 is where the point, and getting all the coefficients right. So if I messed up the -9/2 somehow, I still could get 1 point. So what have I got? 3, 5, 7, and I haven't even attempted D yet. Oh, you guys want to try Euler? Now we're starting at -1 and getting to 0. What's H equal to? 0.5. Can you do Euler tomorrow? 4 more minutes.